Okay, guys. Mani, your test is on when?
Next Tuesday.
Next Tuesday. But
Or
let me give
sorry,
it to you before
next
itself.
Wednesday.
Huh? Next Wednesday.
Next Wednesday.
Yeah, I prefer giving it to you now itself. I think I know your topics. Okay. But if I don't write, you're going to bug me by Tuesday. Okay.
Okay.
Thank you. Hi, Navneet, Samantha, Shreya, Srinita. Okay. Looks like Srinita did not get it. What was that you didn't get it, lady?
Like I didn't get because it was like hard solving it for like because there's two variables and stuff, so I didn't get how to solve for it.
Oh, okay. You're doing algebra at school, right?
Yeah.
That's the deal. Those are the scenarios where you can't study geometry in parallel with algebra. I told you, right? There'll be some topics where you cannot cope when you parallelly study. This was one.
Okay.
Let me go back. You're talking about some questions, right? Let's
Yeah.
see whether those questions are really questions that you can't solve. Then in that case, I'll tell you, I told you, right, at the start itself, I discussed, and if there are some, you have to come back. You have to write it down and come back to this chapter once again after they cover it in Algebra 1. You get it, Amma?
Yeah.
Let's see. Okay, 1 minute, wait, guys. I just want to make sure everybody logged off in the... Dia, what's going on with you?
We have our unit test tomorrow for like similarity.
Okay. Oh, similarity. Okay. 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 Similarity is an easy topic. Okay. What else? They've completed quadrilaterals completely?
Yeah, we already had our test.
Okay. How was it? They finished till squares, huh?
Mm-hmm.
Did you write proofs for that?
I think there was like one question about proofs, but not really.
Not many. Okay. Prisha, what are you doing?
So we just finished our Unit 2 test and we're gonna have our like midterm next week. So we're just like practicing proofs because like for the midterm it's gonna be like a 22-step proof.
Oh, wow. Across what you've learned till far, thus far?
No, this time for this midterm they're just doing like a project basically, so it's just gonna be over proofs.
Oh, I see. Okay, got it. Okay. Chetan, you can educate me, please.
Oh, since last class, we have done special right triangles and how to do them with radicals, and that's pretty much. We went over special parallelograms, and test is on Thursday. That's pretty much it.
Oh, special parallel. Oh, I see. Special parallelograms means squares. Those are the ones, right?
Yeah, and also, yeah, that's pretty much it. And then
Rhombus, squares, rectangles, right?
Okay.
Okay.
And like if you're given one of the diagonals, how to find the other one using Pythagorean theorem.
Oh, okay. Got it. Got it. Okay. So, Srinita, can you tell me what part, what number, quick comma?
Oh.
Part 5. Yeah, I'll try to cover the rest of quadrilaterals and I'll also pitch into similarity. Go
It
ahead.
was part 3. I finished like 4 questions, but like it was like I didn't really get it. The part 3.
Which one? Part 3.
Part
Can
3.
you tell me which question number?
I think it was question 19.
Okay, let me share the screen and let others as well solve this one. It can be a review. How about this? Question number 19, huh?
Oh no, it was question number 20.
20.
Yeah.
What did you guys do for this? Find the value of each variable. What did you guys do?
Miss Priya.
Yeah, anybody can shout out. It's a
Bird,
parallel.
can I annotate?
Yeah, please.
Wait, how do I hit this way I just saw these two
Mm-hmm.
and that they're equal. I mean, 2z plus 7 equals z plus 9.
That's it, right, Srinita? 2z plus 7 equal to z plus 9.
Well, like, how do you know they're equal?
Ah, wow. Okay, wait, I got it. I got your problem. Parallelograms, right? Go to the properties of the parallelograms, right? Main property is this quadrilateral with both sides, both pairs of opposite sides parallel. It defines a parallelogram. Definition of a parallelogram is that. But important properties that you need to know are this ones. You see, I can show it to you. This ones you need to memorize for every quadrilateral we are solving.
Oh, okay.
Diagonals bisect each other. That's the property you're using. Diagonals bisect each other means what? They cut them into two equal halves. You got it, Ma?
Yeah.
I have a question on part 5.
Yes, I will go through Akash, definitely. Okay, I'm going to go slow. It's
Could
okay.
you go through like some of the quadrilateral questions?
Yeah, I'm
Sorry,
going
the
to.
rectangle ones. I mean,
Sorry, I'm going. Yeah, this one.
no, rectangle.
It's on part 5.
Yeah, I'll definitely go. Yeah. Did I clarify your doubt, Srinita?
Yeah.
Okay, so whenever you're not able to solve a problem, go back and see whether you can use any of the properties. The thing is, when you do the homework, you can go back and see, but in your test, you'll have to memorize this for each quadrilateral. You see what I mean?
Yeah.
It doesn't involve two equations, two variables, or anything of that sort. See, this is why I wanted to check. You got it, Srinita?
Yeah.
Okay, now Manav and Akash did have some questions. What are they?
Part 5, question 50.
Oh, wow, you have it so clear. That's so nice.
I think you could do 18.
Which,
Could you do 18 and 19?
which part, Manav?
Part 5.
Part 5, 18 and 19 you want. Okay, wait. And
Yeah.
Akash, what did you want?
50.
18, 19, 15, huh?
50.
50. Okay. Okay, can I go from 18, 19, Akash?
Yeah.
Okay. So for a rectangle, what have you all done? Meaning, what have we done? Opposite sides are parallel, opposite sides are congruent. This is confusing, guys, but it's important to memorize this completely. One thing that can easily help you is all properties of a parallelogram will apply to a rectangle because rectangle is considered as a parallelogram. So what you need, see, oh, here, it's written here, see, rectangle has all the properties of a parallelogram. So if you memorize the properties of a parallelogram, you've already memorized the properties of the rectangle. That's what it means. You see, however, there will be one additional or two additional properties for every quadrilateral, which is very important. See, the diagonals are congruent. See, this is a quite important property which is present for a rectangle but not for a parallelogram. Both.
Wait, it's not for a parallelogram?
Parallelogram diagonals are not congruent.
Oh.
Diagonals bisect each other is a property. That's what I'm saying. Every word has got its meaning and properties should be very clearly defined for each quadrilateral. So that's why I'm saying, see, the notes here, right? They're so clear. Only thing is, you'll have to make sure that you have it in your brains. Thing is, when you start, this defines a rectangle. Basically, this defines a rectangle. What? The starting a rectangle is a quadrilateral with 4 right angles. That defines a rectangle. Very well-known properties of a rectangle will apply from the parallelogram because rectangle is a parallelogram. But the differentiating ones where you are going to be asked questions and problems would be only on these two. Because they are special properties of that quadrilateral. For every quadrilateral, we have this. This we have it for rectangle, right? Similarly, for parallelogram, let's see. See, for parallelogram, there are a ton of properties that distinguishes a parallelogram from a kite or a trapezoid. That's what we learned before, right? Get it? And whatever questions you're asked, right, problems that you will be asked will only concentrate on these because this is what you need to remember and that's the hardest part. So they will ask you questions mainly from these properties, meaning the special properties of the parallelogram. What? Diagonals bisect each other, diagonals separate into two triangles, and if a parallelogram has one right triangle, then it has 4 right angles. Because the last one tells you that it's a rectangle. Rectangle is a special type of parallelogram. Okay, so now this is a very good thing where you can really learn what you need to learn. Just the notes, special properties for all the quadrilaterals. Now coming to, I did write 18, 19, right? I did not solve those. So now this is a part of rectangles homework. We read it through the notes. Now what is that? Oh, the quadrilateral is here. So measure of XYZ. XYZ. What? Okay, 18 I'm solving. XZY. XZY is 3x plus 6. Okay. Measure of XZW. XZW will be 5x minus 12. Find measure of YXZ. You have to find this one, huh? Okay. What should you do, Mano? What do you think you should do?
I realize it now. You have to like add the. You have to add 3x plus 6 is 5x minus 12.
Exactly.
Yeah.
See, this automatically falls through when you go back and see the notes. You got
I think
it?
I messed it up somehow. I don't know.
No problem. So when you have to add these two, find out x value. Once you find out the x value, you can find out this angle. Okay, this will be 90 plus that angle plus your unknown angle will be 180. You can solve the equation. Okay, 18, 19 is also very similar. Do you
Yeah,
want?
you know, you can skip 19.
Yep, 50 is what he asked, right? Okay, who wants to explain 50? Anybody, guys? Please, that you can improve that as well, explaining it to others. Anybody, please volunteer and explain, guys. Actually, it's an important question.
Is it that like those two angles equal 90?
Correct. Why?
Because the diagonal makes it a right triangle.
Correct. Meaning, it is a rectangle. GHJK is a rectangle that's given, and rectangle has 490-degree angles. So, GHJ is 90, HJK is 90, JKG is 90, KGH is 90. That being the case, H is definitely 90. So, a combination of this x plus 8, a sum of, meaning this x plus 8 angle and 3x plus 14 angle are complementary angles which add up to 90 degrees. So you can equate it to 90 degree and find out x. Akash, did you get it?
So they're 90 degrees because it's a right triangle.
Correct, ma. Because rectangle has 90. This is a triangle. This is a triangle. Sum of the angles in a triangle is 180, right? So this x plus 8 angle and 3x plus 14 angle are complementary angles. That means they add up to 90 degrees. You get it?
Yeah.
This is how you solve. Got it?
Yeah.
Yeah, so for HJ, you need to substitute 17 in here. Any questions? Okay. Any other questions, guys? That's it? Okay. Samantha, did you do Samantha? I didn't see your homework. I don't remember, at least. I don't have it
This
here.
week was kind of busy for me, Auntie. Because we're also planning to go to India soon. So there was like a lot of stuff that we need to do. I'm almost done with the homework, so I'll submit it soon.
Sure, ma. See, coming to a rhombus, right? Do you know what is special about a rhombus? What is special about a rhombus? I'll try to, can I extend the class by 10 minutes today so that we can finish a little more in similarity too? And next week we'll finish similarity and complete it completely. Let's see. How about this? Dia, your semester test is next week, right? Dia or okay. Okay, so we'll complete similarity by then. Let's see. How about what did I want to know? Rhombus. Can one of you tell me the definition of rhombus? First, we'll go with the definition and then the special properties. Go ahead. What is a rhombus? Please, anybody, guys?
Parallelogram with 4 equal sides.
Oh, yeah, that's a nice one. Yeah. Parallelogram with 4 equal sides. I will speak in geometry terms. 4 congruent sides. Right? That's the definition. Okay. So if A, B, C, D is a rhombus, it's not even a rhombus by picture. It's okay. So that means all are equal. A, B equal to B, C equal to C, D equal to D, A. Geometry terms, I put a congruent symbol. Any questions here? Okay. Now, okay, where you might be questioned directly in the definition, they can really have questions. How? One main thing is here. If I draw this parallelogram, I should also show that this is parallel. AD is parallel to BC. This is how I show. 2 arrows will show that they are parallel. AD is parallel to BC, meaning slope of line AD is equal to slope of line BC. All these are applications which you should remember to apply. Similarly, AB is parallel to DC, means slope of AB will be equal to slope of DC. This is an easy one, but you have to remember and apply when it comes to it. Got it? Okay, now I have a question. For a rhombus, if I know these 2 coordinate points, x1, y1, x2, y2, would you be able to write the equation of the diagonal? Would you be able to write the equation of the diagonal? You should be able to write the equation of diagonal AC. What do you do? AC, the coordinate points you know. So what will be the equation of this diagonal? How will you write it? I don't want to pick, guys. Akash, do you want to try? If I don't pick, nobody will answer. That's why. Go ahead.
First we'd have to figure out the points, right? So I just
Yeah.
write it in terms of X and Y.
Yeah, so what do you do?
Yeah, so should I say it in terms of X and Y?
Yeah, just describe how will you find the equation of the diagonal. That's fine. How will you find the equation? Just describe what are the steps you will handle. You don't need to, meaning we don't need to write the equation. It's going to be hard. So just tell me how will you find the equation of the diagonal? You have the 2 points.
What's it called? The distance formula?
Yeah. Distance formula will tell the length of the diagonal. But I want to know the equation of the diagonal in the format y equal to m. That's a line, right?
Yeah, so you would use point slope form.
Yep. You will find out the slope from these 2 points. x2 minus x1, I'm sorry, y2 minus y1 by x2 minus x1. Slope you'll find out. And then what?
You put it into point slope form, right?
Correct. Okay, I'll put it into point slope form. Correct. I'll put it into point slope form. Once I have the slope, let's say I have 3, then 1 of y2 minus y. So here I'll put it x2, y2. I can substitute any one of these points and have the equation ready. Does it make sense? Now I have another question. Please, whoever knows should raise. Manya, otherwise you'll help me. Or Chetan help me. How will be the slopes of the diagonals? What will be the nature of the slopes of the diagonals in a rhombus? What will be the nature of the slopes of the diagonals in the rhombus?
They're equal. Wait, hang on. The diagonals?
Navneet has the answer. Wow. Okay. 1 minute, Navneet. Yes. Chetan, do you have an answer?
Equal.
Okay.
They
I'll pause you. Okay.
They bisect each other.
True. So what happens? Navneet, you have the answer. What is the nature of the slopes of the diagonals?
They would be perpendicular.
So what? What will be the nature of the slopes? How will the slopes of the diagonals be?
They would be negative reciprocals.
Yeah, they will be negative reciprocals. Do you get it? All of you, do you get it? See, I told you, right? Every quadrilateral has a definition and some properties associated with it. So now let's go to that special properties of rhombus that's going to be the center of your questions. What differentiates a rhombus from the other ones, other quadrilaterals? These three properties. One is all the sides are equal. Okay, that is only possible in a square. You see? So now all the sides are equal. Diagonals are perpendicular. Okay, and the third one is, I forgot, guys. Diagonals are perpendicular, all sides are equal. Special properties. Yeah, so here the third one is on the angles, I think. So here the diagonals bisect vertex angles. What is that vertex angles? Let me show you. If I have a rhombus, you know all the sides are equal. This is property number 1. Property number 2, the diagonals are perpendicular, slopes are negative reciprocal. So slope of ABCD is the rhombus. So now slope of diagonal BD is the negative reciprocal of the slope of diagonal AC. Any questions still here? The last one, diagonals bisect vertex angle. That is very important. Meaning this angle, see the angle, you're drawing the diagonal, right? From a vertex point. That vertex point angle is bisected by the diagonal. Diagonals bisect the vertex angles. You get it? See, 3 marking means those two angles are equal. Any questions here?
Miss Priya, I have a question.
Yeah, go ahead.
So, my teacher said something about like the opposite angles are congruent. Is that true? Or is that what you just explained?
No, I did not explain that. Why I did not explain that, I'll tell you. Opposite angles are congruent, right, Amma? But
Yeah.
was that not a property of a parallelogram, Anya?
Yeah.
It is, meaning I feel like it's a parent property inherited to the child. I consider it like that. See, opposite angles are congruent was a property of a parallelogram which the child inherited. That's how I think about it. You see, child is the rhombus. This child came from the parent parallelogram. You see, so the parents' traits got inherited. Parents' characteristics got inherited. So parallelogram has it as opposite sides are congruent, opposite angles are congruent, and consecutive angles are supplementary, right?
Yeah.
Those properties naturally descend to all the rectangle, the rhombi, and the square. Does it make sense?
Yeah.
So the thing is, you have to remember all the properties of the parallelogram. So that defines that, right? So the properties of parallelogram all apply to rhombus. Okay, only the special properties we are discussing for each quadrilateral.
Okay.
Get it? So these three differentiates. Okay, right now they give you ABCD. They give you 4 coordinate points. They ask you, hey, whether this is what type of a quadrilateral is this? When you're asked that question, only the special properties are going to help, because if it is a rhombus, you have to prove that this is a rhombus. You cannot say this is a parallelogram and stop there. You have to go to the most specific one. The most specific one comes only from the special properties. You see, because you cannot decide between a rhombus and a parallelogram. Why? Because all of the properties that apply to the parallelogram apply to the rhombus. You see? So To prove that something is a rhombus, you have to prove one of the three, which are the special properties that are seen only in a rhombus and not seen in a rectangle or a parallelogram. Got it?
Yeah.
You have honestly that, but you have to be aware of every property of the parallelogram because it applies to rhombus, that applies to rectangle, that applies to square. However, some special properties differentiate a rectangle, differentiate a rhombus, differentiate a square. The youngest child is the square because that child has the properties of all rhombus, rectangle, parallelogram. But there is one property that's one or two properties that specially distinguishes a square. To prove it is a square, you have to prove a lot. So that's how I think the parent is the parallelogram. From the parent, the rectangle is a child, rhombus is a child, square is also a child, but square is the youngest child. Because square has the properties of the parallelogram, has the properties of the rectangle, has the properties of rhombus. You can call a square as a rhombus. You can call a square as a parallelogram. You can call the square as parallelogram. But the other way cannot happen. You cannot call a parallelogram as a rectangle or as a rhombus or a square. A parent can't be called as a child, but a child comes from the parent, right? So you can call that as a younger, the young one of the parent, literally. I don't know whether I'm making sense. Maybe these all I'm telling for you to remember. Can I move on? Meaning, I don't want you to confuse in a test. How do you decide? If you really remember this parent-child relationship, you'll really remember everything. Okay, now in a rhombus, we discussed, right? See, your class will run. Wait. I really want to go to more of rhombus questions. Where are our rhombus questions? Let's see. Okay, how about this? This one is a very good one. Let's try this one, please. Okay, let's try this one. I want you to tell me, guys, you're going to work out, okay? There's a lot of working out here, okay? But this one problem we'll do, and that's the problem we'll do. Okay, let's try this one. I want answer. Shreya, I'm waiting for your answer. Shrikar, I would like to see your answer. See, I told you, right? There are 4 vertices given. Can you categorize this as a square, rectangle, or a rhombus? See, they have answers like 1 only, 2 only, 3 only, 2 and 3. It can be a rectangle and a rhombus because rectangle was a parent. 2 and 3 means rectangle and a rhombus. In that case, it has to be a parallelogram. But if it can, yeah, it can be a rectangle and a rhombus, correct? Oh, wow. Yeah, that's a difficult question. I would really draw, guys, these problems. Oh, you got it already? Mano, did you get it already?
Yeah. Oh, wait.
Did you get it so soon? Maybe, I don't know. I don't know. I have to see what are the points. -1, 7. Q is 5, 5. But how did you get it so fast, Manav?
Oh, wait, I didn't use the coordinates.
Huh?
I didn't use the coordinates.
Then how did you do?
I just thought that it was a parallelogram and it had to be like this. It had to be a rectangle.
That's not convincing me, honestly. Oh, Akash, really? Okay, I don't know. But Akash, it doesn't seem to be a square to me because I don't feel from the coordinates itself, I don't think it's a square. There are no 90-degree angles, right?
I think they all are.
Hmm?
I think they all are 90.
Let me check. I don't know. How did you decide that?
I drew it.
Oh, you drew it. Oh, 5. But wait, 5 and 3. Oh, -1 and -3. Oh, I don't know. Okay. 7 and 5. 2 up. Okay, have I written it wrongly?
Yes, Priya.
Yes, ma'am.
So didn't
Chetan,
you
I'm sorry, Chetan. I didn't read it out to you. Wait, Chetan. Sorry, Chetan. Go ahead.
um didn't you say if like the properties of a like a rectangle or for if you want to find out a square, if the properties of a rectangle and rhombus, since they're like the children of a rectangle, couldn't it be classified as a square?
Um, to be very honest with you, I did not tell you the properties, the special properties of a square till now, right, ma'am?
Yeah.
You
So you
did
did
draw
not.
your S correct. Your S should be like above the x-axis.
Ah, okay. See, that's where I got confused. S should be above x-axis. Yeah, then that makes sense to me. Akash, very good job. Okay. I feel like you're right, Akash. Okay. Let me check the answer key as well.
And on a rhombus, isn't all the sides 90 degrees?
Rhombus is not all 90-degree requirement is only for a square or a rectangle.
Oh.
Okay, square requires also, see, the special property of a square is just that all sides are equal and all angles are 90 degree. Manya, to answer your question, square, the only two main properties that will distinguish is both should happen. All 90 degrees and all sides are equal. Using distance formula, you have to find out the distance of all the sides. They should all be equal.
So isn't that technically what you do for rhombus too?
Rhombus does not, Emma, correct. If you're able to prove it is a square, right? Definitely it's a rectangle and a rhombus.
Okay,
You
yeah,
get it? Meaning that's the youngest child. If you're
yeah,
able to prove the child, then definitely it came from the parent. Definitely it is a rectangle, it's a rhombus. You don't have to worry about it. You got it? So that's
yeah.
the clever way of handling this. If you're able to prove it's a square, then you don't have to even, meaning you have to prove, but then at least you tell the answer to me, you don't have to. You get
Okay.
it?
Yeah, that's all I needed. Thank you.
That's right. Yes, Shrikar, Navneet, you all got it. Shreya, can you explain how you got it? Samantha, how did you get it? Akash, correct. Manav, just check your answer, Manav. So always
think-
like that, guys. If you prove something is a rectangle, you already know it's a parallelogram. If you prove something is a rhombus, you already know it is a parallelogram. But if you prove it's already a rhombus, please remember that rectangle is not a parent of the rhombus. You get it up? Parallelogram is the main parent. The children are rectangle rhombus. Okay. And then down beneath you have.
If you prove it's a square, you can say it's anything, right?
Yeah, correct. Square is the youngest child, meaning second generation child, I will think. Okay, so this is a quadrilateral. This is how it goes. It should be in your brain always. And then you have the parallelogram. Okay. My problem, this is quadrilateral can be a trapezoid. Okay. The definition of trapezoid really varies. Okay. Different textbooks are referring to trapezoid. I don't want to bring the trapezoids here. Particularly Texas standards have a different definition of trapezoid when compared to Common Core. So I don't want to bring that in here now. Let's not confuse. Parallelogram. And then you have, see, parallelogram. Yes, from here you can have a rectangle and a rhombus. It's like this. This one you should always remember. And then this comes like this. Square is a square's parent are rectangle and rhombus, I would say. So if you prove it as a square, it's all rectangle, parallelogram, and a quadrilateral, and a rhombus. Let me see whether I can get this picture from somewhere and show you clearly.
Wait, why can't rhombus be from rectangle?
I'll tell you. I'll tell you. Good question though. 1 minute more. This is the one I wanted to show you. I'm getting it. Yeah, but this is going to confuse you. Oh, see, this is exactly the picture I wanted to show you. Can I erase this or whatever I've written, I'll erase. I'll discuss the answers with you slowly, but let's see. Chetan, can I read out the question? I took time, I'm sorry. The vertices of a parallelogram are P minus 1, 7, Q 5, 5, R 3, minus 1, and S minus 3, 1. Did you get it? Chetan?
Yeah. Can you repeat them one more time?
Yeah. P minus 1, 7, Q 5, 5, R 3, minus 1, S minus 3, 1.
Okay.
With these coordinate points, you tell whether it is a square, rectangle, rhombus. It can be a combination as well.
Can you read that again?
Which of the following terms apply to the parallelogram? Number 1, square. Number 2, rectangle. Number 3, rhombus.
Well,
Answer can be more than one as well.
can you read the points?
Points are minus 1, 7, P. Q is 5, 5. R is 3, minus 1. S is minus 3, 1. You got it?
No, I only got the first point because it's hard to set up.
It's hard to set up. Huh? Okay. I'll repeat it again. It's okay. P is minus 1, 7.
Okay.
Q is 5, 5. R is 3, minus 1. Did you set up the 3 points?
Yeah.
S is minus 3, 1. Okay. Now, did you get it, Chetan?
Yes.
Okay, for the others, let's move on, please. Now, see, quadrilateral can be a trapezoid as a parallelogram. Guys, I don't want to discuss the definition of a trapezoid. Trapezoid in our case, right? Texas standards define it differently and Common Core defines it differently. Those who are studying in Texas, you have to follow this trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay, so let's go with it for now. Okay. Parallelogram, there is a slight variation in Common Core when they define it. Parallelogram, a quadrilateral with two pairs of parallel sides. So here, Akash question was, why can't rectangle be a child of a rhombus? Why is it a pair? Two children, right? Why is it like that? Anybody, any answers? I don't want to pick out. You're going to tell me. I'm going to wait and watch.
Oh, I'm sure what you said.
Why is a rectangle not a child of rhombus or a rhombus not a child of a rectangle?
Is it because both of them have two pairs of parallel lines?
Oh, is it because the rectangle has something that parallelogram doesn't?
If the rectangle doesn't have equal sides.
Go ahead. What is it?
It doesn't have equal
the
sides. All equal sides.
And
angles.
which? Sorry, Shrikar. What was that?
The rectangle, no, the rhombus doesn't have 4 right sides, and the rectangle doesn't have all equal sides.
Correct. That is one that differentiates a rhombus. Rhombus requires that the 4 sides are equal. Rectangle doesn't have to have. So the mandatory property of a rhombus is 4 equal sides, which is not a mandatory property of a rectangle, meaning it can have, it need not have. You see what I mean? So if you want to prove it as a rhombus, then you have to prove that the 4 sides are equal. And you know what? Diagonals are perpendicular and diagonals bisect vertex angles is a property of what? Just now we studied that, right?
Okay,
Just, what is that?
can you repeat the points one more time?
Okay. Few minutes, Chetan. I'll come back. Is that okay? So I'll come back, Chetan. I'll detail you everything. So rectangles have diagonals congruent. That was the only property we learned about. Let me write it down. Otherwise, it's very hard for you to follow. What differentiates a rectangle and a rhombus? Rectangles, we just studied the diagonals are congruent. That's all we studied. But when we discussed rhombus, we discussed diagonals are perpendicular and what else? Diagonals bisect vertex angle. Bisect vertex angle. So we studied this for rhombus, the special properties. Here, only thing was diagonals were congruent. Here we studied diagonals are perpendicular, diagonals bisect vertex angle. Did you remember that? So rhombus properties are different. Requirements for it to be a rhombus is different from that of a parallelogram. Am I making sense, Akash? Akash. Akash. Hello, Akash. Okay, Akash is not there. Okay. So, did it make sense for all of you? Did it make sense for all of you?
Yeah.
Because the diagonals bisect each other is common to both. Because it's a part of the parallelogram properties, I'm not writing it here. You get it? I'm not writing the parallelogram properties here. In parallelogram, we study diagonals bisect each other. Diagonals bisect each other applies to both. So that can't differentiate the two. But what can differentiate is diagonals are congruent in a rectangle. Diagonals are perpendicular in a rhombus. And the rhombus. And the diagonals bisect vertex angle only in a rhombus. Okay, so they have different properties. So they are two different children of parallelogram. Any questions here? Okay, now with one more question, we'll jump to similarity. Okay. I'm not solving many questions, I know, for want of time. That is why please do the homework. And if you have questions, you come and ask questions. Make sense? Okay, how about this? This is good. Okay, how about this? Diagonals of a rhombus are these two. Which of the following are necessarily true? Ayo, hey Chetan, sorry Chetan. You want the points, right, Chetan? Chetan? Should I tell the points to you? Chetan, you there? We're not able to hear you.
Yeah, Auntie, can you hear me now?
Yeah, I can hear you. Can I go ahead and tell the points again to you?
I think I actually got it. Is this a fig? You were asking what figure this
Yeah,
is. It a rectangle?
it is a rectangle. Is it a rhombus then?
I don't know how to say that yet. Like how? Like I slope and
Okay,
each
view
two.
this. I'm sorry. Go ahead.
Like the way I found out it was a rectangle is because the slopes of like two of the slopes were the same on opposite side of the figure, and then two of the slopes were the same on the other side. But I don't know how to figure out if it's a rhombus or whatever.
Rhombus means they will be equal. See, okay, the best way to cater to this question is if you prove that it is a square, right? Then it is rectangle and rhombus, right? For you to prove it's a square, right, you have to prove that the sides are all equal and there are 4 90-degree angles.
Okay.
Make sense?
Yeah.
Shreya, are you getting it, ma? I am not getting correct answers from you. For this one, I'll wait.
I don't think it's 90 degrees.
Check, ma, because see, the sides AB, BC.
How do you check if it's 90 degrees?
You tell me. How do you check two lines are 90 degree? They are perpendicular. How do you prove that they are perpendicular?
Oh. If the slopes are the reciprocal, right?
Good. Negative reciprocals.
Yeah, negative reciprocals.
Good. That's how you prove.
This one isn't.
Actually, they are. Then you have gotten the points incorrectly.
Okay, wait. Tell me the points again. They match.
Okay, you want me to tell the points again? Okay, I'll tell you. I don't have it. Wait. Minus 1, 7, 5, 5, 3, minus 1, minus 3, 1.
Yeah, that's correct, Auntie.
Okay, I'll deal with it at the end. Is that okay?
That's fine.
Yeah, I'll definitely deal with it at the end. Wait, okay. Manya correct, Prisha correct, Diya correct, Navneet correct, Manav correct. Akash went off. He has messaged, I didn't see. Okay, others, where are the answers? Srinita, can I get answers from you? Prisha sent, right? Yeah. Shreya, can I get your answers? You have to explain your answers.
Yeah, I'm just double checking.
Sure. Chetan, I did not give you the problem. It's okay. We will skip this and go to the next one.
Okay.
Manu, did you send? Akash, that's not the answer. It's not necessarily true. Did you see that, Akash?
Yeah, I sent my answer.
Yeah, Manu, I got your answer. That's fine. Samantha, that's not correct, ma. See, Samantha, the question was which of the properties not necessarily true? You didn't see that?
So like
Meaning it's not, it need not be. Meaning rhombus, the very special property, what did we discuss? The diagonals bisect each other and they bisect vertex angles, right? So they have to be true in a rhombus.
yeah.
And we also discussed that the diagonals are perpendicular, right, in a rhombus. But should the diagonals be congruent? No, right? That only happens in a rectangle. Remember?
Yeah. It could be true, but it doesn't need to be.
Yeah, it could be true, but it doesn't have to. You got it? Yeah. Shreya, the answer is G, correct. Shrikar, correct. Srinita, did you get it?
Yeah, I thought I didn't read the question right. I thought it said.
Oh, which of the following is true?
Yeah.
Is true now. There are 3 others that are true, 2 others that are true, right?
Yeah.
Okay, now Akash, did you understand?
Yeah.
Okay. So now, okay, you know what? I want to touch similarity whatsoever. Wait. Okay, I'm going to give the rest of it as homework. Okay, similarity. Module 6. God. 1 second, guys. Oh, this is not the one. Oh, this is my problem. Dilations and similarity. Okay. 1 second, guys. 1 second. Okay, I want to check certain things. Hold on. I don't have it ready, but I want to do. Similar triangles. Okay, I have it. Okay. Good. Okay. We have always studied congruent triangles, right? We have always studied congruent triangles, meaning till this date, what is congruent? Sides are all exactly the same, right? Two congruent triangles means this side is equal to this side is equal to this side is equal to this side. So they are congruent, same size, same shape. Okay, but what now we are going to study similar triangles. Similar triangles means there's a triangle. It's a continuation of grade 7. Okay, so similar triangles will indicate same shape, different size. Okay, the size meaning if this is here in congruent sides, we also learned this one. Remember, CPCTC. Corresponding parts of congruent triangles are congruent, meaning corresponding parts. This is the corresponding part for this one, correct? This is the corresponding part for this one, correct? This is the corresponding part for this one. So here, these are the corresponding part. Similarly, angles as well. This is the corresponding, meaning it depends on how they give. The order of the letters matters. A, B, C is congruent to, let's say A, B, C is congruent to F, E, G. Let's say is congruent to triangle FEG. If they give you this, you have to follow the order. FEG means the first two letters, second two letters, second two letters. AC side is a corresponding part of FG. So similarly, the same thing applies for similar triangles. But the only difference is this is FG. Now I am saying triangle ABC is similar to FEG triangle. That means AB is proportional to FE. AB is first two letters, is proportional to FE. See, I changed it a little bit here. Here it was ABC. I went like this. Here, do you see it's in a different way, but then when I wrote down the letters, this is very deceptive. Don't look at the diagram and conclude. See the order of the letters. AB is proportional to FE. It's not congruent because they are similar means I have to multiply this side by some factor to get this. That is called the scale factor. That multiplying factor is called the scale factor. Similarly, the BC side is proportional to EG side. So I have to multiply BC with the same factor X to get GE because it's bigger or smaller, you don't know. If it is smaller, then the X factor will be less than 1. If it is bigger, the X factor will be greater than 1. Now the last one is AC, this two, first and last letters, FG. So I have to multiply by a factor X to get this. Any questions? So in this case, we say AB, you can write out proportionality. Literally, AB by FE, the ratio. This AB by FE gives you what? AB by FE or FE, AB by FE is nothing but 1 by X. FE, FG by AB is X. So that ratio, right? Meaning you multiplied AB with X to get your FG. So AB you multiplied with X to get FG. So X can be written as FG by AB. FG, sorry. I think I'm confusing, guys. Hold on. Let me redraw it correctly. ABC, ABC. Let me try a smaller one this time. Okay. This is FEG. I really want it to be FG. Okay. Triangle ABC. I want to change it and show similarity. Triangle. See ABC going in counterclockwise direction. I'll do it FG. I'm saying triangle ABC is similar to triangle FGE. What does that mean? AB is proportional to FG. Those two sides are proportional. Now, then AC. What happens to AC side? FE. And then the last one, BC is proportional to GE. Any questions here? That means there is always a factor that I multiply BC with X to get EG. I always multiply AB with another number. It can be a fraction or a big number. That will be equal to what? FG. Similarly, I'll always multiply ABBC CA with the same X factor to get FE. See here, we say the sides, the corresponding sides are not congruent in similar triangles. When the triangles are similar means they can differ in sizes, but they are the same shape. So corresponding sides are proportional. What are corresponding sides? BC and EG are corresponding sides. AB and FG are corresponding sides. CA and FE are corresponding sides. Now I can write out the ratio. How can I write out the ratio? X is EG by BC, right? EG by BC will be the same as FG by AB. Will be the same as FE by CA. Any questions with this? Any questions with this? This is the proportionality equation for similar triangles. You can write it in different ways. You see, meaning this can go here, this can be exchanged. Similarly, the place of these can be interchanged too. When you consider this side divide by the other side of the other triangle, that is one way of doing it. The other way is you can say AB by BC. In the same triangle, you can say AB by BC will be equal to FG by G. Shrikar, are you following?
Are all equilateral triangles similar?
Equilateral triangles are, yes, I can say all equilateral triangles are similar. One thing did you observe? The sides are proportional, but what happened to the angles? In congruent triangles, it was very easy. If this was 60, this will also be 60. And the sides will also be 3 means 3, 4 means 4, 5 means 5. But what do you think about angles in similar triangles? Similar triangles means one will be a bigger side. One
They're
will
the
be
same.
Same.
the angles will remain the same because they cannot double or triple like the sides. Even if the triangle becomes bigger, the angles are still congruent. Only the sides are proportional. That means you can triple, double, quadruple to get the other triangle. Or you can half it. Half the original triangle becomes the second triangle. That is fine. Sides are proportional. So you always multiply by a scale factor, which is the constant of proportionality, to give the other side. But the angles are all congruent, meaning the corresponding angles are congruent even in similar triangles. Manya, are you following?
Yeah.
Okay, now let me ask you this. I'm just going straight into a difficult problem. Can we try? Okay, I'll hold you for 3 more minutes and leave you. Okay, let's see this one. 3 or 5 more minutes. Okay, so this one. Let's see this one. Hey, literally, guys, I am sitting. Okay, I'm 1 hour ahead. Okay, please, for you, I'm sitting. So let's do these. How about this? Meaning I want to cover a little bit more, so I'm comfortable for next week. How about here? I'm saying, let me write out the similar triangle order. Order is quite important, guys. Okay, let's see. Order is quite important. Okay, so you want to know what is similar to what, right? Let me give you this. AFD. AFD is similar to ABC. That you on seeing it, you should know. AFD. Chetan, I know I'm not translating this. I'll come back. Triangle AFD is similar. This is similar. This is congruent. This means congruent. Two equal to sign with an S on top, with an inverted S on top. It's congruent. Just the inverted S means similar. Okay. Now AFD is similar to ABC. Can you find out? See, this is just a grade 7 problem. Same problem I have worked with you in grade 7. This is a revision. Can you try that for me?
Sure, you're talking to me.
Not really, Chetan. Chetan, I'm not dictating the problems. I will come back and clarify the last one that we worked with. Right now, let me go ahead and just explain. Similar triangles I'm explaining. I know that your school covered it, right? We
Wait,
know-
so are we just proving that triangle
I'm not-
AFD is similar to ABC?
I told you that this is similar. I'm just asking for the X value.
Oh, okay.
If you don't know, it's okay. You can let me know. Oh, wow, that's correct, dear. Class. Akash, as a follow-up of your question, right? Can I ask you this?
Yeah.
Two, okay, a trapezoid and a parallelogram. Are they similar? You asked about
Trapezoid
two. Hmm.
and a parallelogram,
Hmm.
are they similar?
Hmm. You can
No.
say always, sometimes never. Any one answer.
Sometimes.
Hmm.
Actually, never.
Never is correct. Two right triangles?
Sometimes.
Good. Somebody wants to answer similar question? Two obtuse triangles, who wants to answer? Your answer can be always, sometimes, never. Are they similar? I'm asking. Two obtuse triangles. Anybody wants to say? Sometimes two obtuse triangles are similar. I'll let you go in 4 minutes. Let me please do this. Oh, Samantha, what is the answer for that? Please find the root and tell me.
Okay.
You're making my head break.
Okay.
Mano, correct. Diya, correct. Can I do it on the board? Shreya, what did you get? Manya, what did you get?
I'm kind of confused.
Confused. No problem. No problem.
have it, but like I'm not like sure.
Okay, no problem. See, you have to find out X value, right? For that, I need to write some proportionality equations. What equation can I write? Smaller triangle AF I need to include. Okay. So the bigger triangle AB, that's the corresponding part. So that smaller triangle, this is small triangle by big triangle side, corresponding sides, I'm writing equations. Now, what do I know? This one I don't know. So I have to find this basically. Okay. Now, I have to involve this one, AD side, because I know that 9 is there. In the small triangle, AD is there. In the big triangle, the corresponding side is AC. What is AC? AC is 9 plus 6. AD is 9. Small triangle AF is what you need to find. That is only X. AB is 18. So now, to solve proportions, you always use the cross multiplication strategy which we used in 8th grade. 7th grade. 9 times 18 divided by 15 is X. So you can simplify this using 3 3s are 9, 3 5s are 15. Now you can say 18 times 3, 8 3s are 24, 2 3 1 is 3, 54 by 5, which is 10.8. Yes, all of you got it? Manya,
Yeah.
not yet? Did you get it?
Yeah, makes sense.
Okay. Okay. Last one, guys. Last concept at least. Just like we had congruence, right? We are going to discuss different types of similarity. Okay. SSS similarity means the side, the one triangle to the other triangle, compare all the sides are proportional. SAS means what? The included angle is equal, the two sides are proportional. AA means what? Two angles of a triangle is congruent to another angle of another triangle. Here, guys, I really want you to understand in congruence, we learned a lot, right? We started with SSS, SAS, and we also did ASA, AAS, and then HL. We did all this in congruence. Please, you have to remember what will apply for similar triangles. Similar triangles to this week, we'll do only AA, SSS, and SAS. See, these two are the same. We'll start with only this. We have AA similarity. We don't have AA congruence. You got it? We'll have to remember these. You'll have to remember these. Any questions?
No.
Okay. Okay. So I'll give you just two triangles. Let me know what similarity that is. Hold on. Just give me a minute. One second, guys. I'll get you. Hold on. I just want to take out the attendance right now. What did I do? Okay. So let's go here. Okay. So we are only going to, I'm going to show you different triangles. You will categorize them as AA or SSS or whatever. Let's see this one. With that, we'll conclude today. How about this? We'll do problems next week. Oh my gosh. How about this? Not able. What is going on? Okay. How about this? Wait, guys, something is not right. Oh, my pen. Okay. Okay, I'll clear this. Go ahead. What type of similarity is shown? Are they similar, first of all, and what type of similarity is shown? Are they similar? First, you need to answer. What do you think? Are they proportional? Do you see the sides? Anybody can answer, guys, please. Are they similar?
No.
Hmm?
No.
No, because even if you consider side by side, right? Let's say, see right angle that goes towards the hypotenuse, right angle that goes towards the hypotenuse. So the ratio between that is 20 by 18, right? And the other one is that goes away from the right angle that goes away, right? So from the right angle that goes away. So that will be 36 by 24. No, they're not equal at all. So they're not similar. Here, they're not similar. How about this? Can you tell me whether this is similar? I have given you the three similarity that we will discuss as well. So you can see that and say the answer too. I'm not asking you one by one as well. I'm just understanding whether at least 5 or 6 of you are understanding. Are the triangles similar? If they are, you have to say what similarity it is. You can shout out.
Yeah. Side angle is side angle side.
Side angle side. So why the sides are proportional? 16 by 18 is the same as, no, that's not correct. 12 by
I
18.
don't think they're similar though, right?
It is. It's
Why?
16 over 24 and 12 over 8.
Yeah,
Oh,
16 by
never
20 is the same as 12 by 18. So it's a little tricky. You have to see and then understand which side is corresponding to which side. Okay, it is, yes, it is similar when you think about it. See here, this side by this side. See, 12 by, am I making sense? Yeah, 12 by 18 is the same as 16 by 24. This is also 16, this is 2 by 3, right? This is as well 2 by 3. So it is SAS, SAS similarity. Make sense? Okay, guys, I'll stop here. Can I let you all go? I'll continue similarity next week. Any questions, you can stay. Chetan, I can go over that points now.
Ready.
Give me a minute, Amma. Any questions? Okay, guys. If you don't have any questions, we can stop here.